sharing my screen and going to your class and going to the first page. So today we're going to look at a little bit more of conditional probability and expected value. Homework 11 is due, oh my heavens, it's not due in 76. What happened there? This is what happens when I type at something crazy like 5 o'clock in the morning. Due today. Does it look better? Homework 12 and 13 are both due on the 21st. Exam 2 is on the 23rd. Again, during last time, probably on the 21st, we'll go over the review sheet and then we'll discuss for exam 2 whether it's open from the 21st to the 23rd or from the 23rd to the 24th. Before we get started from where we left off, if I remember correctly, we had gone through all of the notes on conditional probability and we're looking at examples of different types of probability problems. Does anybody want to look at anything from the homework?
Did we cover the last question of 12? I think it is, because it's the different birthdays one. I know that much.
Okay, grab my calculator for this one. This exercise is on probabilities and coincidence of shared birthdays, complete parts A through E. If two people are selected at random, the probability they do not have the same birthday is 365 out of 365 times 364 out of 365. Explain why this is so. Ignore leap years and assume 365 days in a year. This person can have any birthday, so they can have their birthday on any of the
365 days.
365 days. In order for the second to not have it, it can be on one of the remaining 364. Everybody all right with that?
Yep.
Great. If 5 people are selected at random, find the probability that they all have different birthdays. Well, let's see, if I were to expand that reasoning for 5 people in the first one, it could be any 365 out of 365. The second one can be 364 out of 365. The third one can be 363 out of 365. Then 362 out of 365. Then 361 out of 365. Does that make sense?
Yeah, hang on, just writing this all down.
Just what you did with the first 2 birthdays, except we're going to have 5 fractions instead of 2.
Yeah.
So typing in my calculator, I'm opening parentheses. The numerator is 365 times 364 times 363 times 362 times 361. I'm going to close my parentheses and then put that over in parentheses. I'm going to say the denominator is 365 to the 5th. And so is
And so you're multiplying the top and then adding the bottom in parentheses.
I'm multiplying the top, 365 times 364 times 363 times 362. Oops, that's why my number was so off base. It would help if I typed right times 361 divided by 65 to the 5th. And to 3 decimal places, is anybody else getting 0.973?
Yes.
I got 0.972.
Round though, don't just truncate, round.
Oh, okay.
Okay, So there we've got 0.973. Fantastic. I'm going to erase what I drew. If 5 people are selected at random, find the probability that at least 2
Bless you.
have the same birthday. Now, for at least 2 of them to have the same birthday, that means 2 or 3 or 4 or 5 of them have the same birthday. Isn't that the complement of each of them having a different birthday?
Yeah.
So this is going to be, if it's the complement of the preceding one, it's 1 minus 0.973, which would
Okay.
be 0.027. Kind of like when we were looking at that hurricane and rain question in class.
Okay.
The complement we subtract from 1.
Okay. Okay.
20 people find the probability that at least 2 of them have the same birthday. Well, what you're going to do is you're going to do here the same work that we did up here for 5, except instead of multiplying 5 numbers and dividing by 365 to the 5th, we'll multiply together 20 numbers and divide by 365 to the 20th. And subtract that from them. But you see how it's the same process, it's just you're going to be doing a lot more multiplication.
Yeah.
Right, Adam?
Uh-huh.
Better?
Mm-hmm.
Okay, great. Does anybody want to look at any of those other problems from this assignment?
Isn't there still one more step? Because it says to E.
I'm going to cheat. E, show that if 23 people are selected at random, the probability at least 2 of them having the same birthday is greater than a half. So the probability that 23 share the same birthday, it's going to be the same work, except instead of having 5 or 20, we'll have 23. And then we subtract that from 1, which would be bigger. So it's just doing the same thing, but with 23 instead of 20. Okay, Adam?
I think so. It's just, sorry, there's just a lot of steps to this one, so.
Yes, there are. There are.
Okay.
All right. Does anybody want to look at any of the
Okay.
other ones? Then we're going to push the homework aside. And last class, we were looking at that idea of conditional probability. And we had said that the probability of A given B is the probability of A occurring given B already occurred. And I think we referred to the idea that we're going to, in some ways, restrict the sample space to be having it. And I'm guessing at this stage of the game that phraseology is about as clear as mud. And so I'd like to pick up on that sheet of examples we were looking at. When we were looking at it before, we only got through the 2 weather questions. So, does everybody got this down?
1 second.
Ready?
Okay. Yeah, okay.
So, I do believe, did we already do sum of 15 through 20, 25 and 26. Let's look at 33 through 36. 33 through 48 involve probabilities with dependent events. We've got a box of chocolates. There are 30 chocolates in the box. All are identically shaped. 5 are filled with coconut, 10 with caramel, and 15 are solid chocolate. You randomly select one, eat it, and select a second. Find the probability of getting 2 solid chocolates in a row. With this question, what's the probability that the first one is a solid chocolate? In my box, I have 30 and 15 are solid chocolate. We got our solid chocolate. Yum, 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 yum. We ate it. What's left? How many are left in the box? Total.
14.
14 solid chocolates out of 20 candies.
29.
Sorry, I wrote 29 and I misspoke. I said, and so is everybody all right? If I go through and multiply that, I believe that reduces to 7 over 29.
Okay. Yeah.
We're reopening a new box of chocolates, 30 in it. How many of them are caramel? 10. So the probability of the first one being caramel is 10 out of 30. Yum, 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 yum. That was good. What's the probability of the second one being caramel?
9 over 29.
9 out of 29. And so I believe that that reduces to 3 out of 29. And let's look at one more. 35 says first candy we want is a coconut filled chocolate. And we're doing a new box. There are 30 in the box. How many of those 30 are coconut?
There's
5.
5, yeah.
5. Yum, 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 yum. That was good. How many are now left in the box? Total 29. Of those 29, how many are, I said caramel, I should have said caramel. 10?
10, yeah.
And so when we go through and multiply this out, we get 5 over, oh my heavens, 29 times 3 is 0, 7, carry the 2, 870? No, that's totally wrong. What's 29 times 3? 90 less 3 is 87. Okay? General idea of those, all right. And that dependent events. Now, when I look more at that idea of conditional probability, I have these numbered discs in a box. One is selected at random. It asks me, what's the probability of selecting a 3, given a red disc is selected? This is that conditional probability that given a red disc is selected. So I'm restricting to only reds. So how many reds are there?
5.
5. And so is everybody right? If I know it's a red disc, my sample space is only those 5 red discs.
Yeah.
How many of those 5 have the number 3 on them?
1.
1. This time, next question, I'm only looking at the yellow discs. If I'm only looking at the yellow discs, how many are there?
3.
And of those 3 yellow discs, how many have the number 7 on them?
1.
1. 51 says, what's the probability I get an even number given that it's a yellow disc? So we're only
2.
looking at the yellow disc. It's beautiful. 2 over 3. Now I want to skip to 53. No, I want to take that. No, I want to take that back. I did the wrong one. Okay. I'm going to make up my own one here. I'm tossing aside their questions. What's the probability that I get yellow given an even that's selected? Now, 51 said an even given a yellow is selected. Our made-up problem says a yellow given an even is selected. Those two sound awfully similar, don't they? But this time, we're restricting our thought process. We're only looking at the even numbers. If I'm only looking at the even numbers, I'm only looking at 2, 6, 4, and 8. And if I'm only looking at the even numbers, how many are there?
4.
4. And of those 4, how many are yellow?
2.
And so do you see the difference between the two wordings? Okay? So now I'm going to sit down and look at that same type of question, but I'm going to look at it presented in a table. So we've got this table. We want to express as a decimal, round it to 3 places. So I'm going to grab my calculator. We'll set up the fractions and then turn them into decimals. What's the probability that somebody is not divorced? Is everybody all right? When I see that word not, I think 1 minus. Now from this table, what would be the fraction for divorced?
22.8 over 69.2.
22.8 over, what's the total number of people in this table?
69. Oh, I see.
35.8.
Yeah.
Okay.
So now I'm turning my calculator on and I'm typing in 1 minus 22.8 over 235.8. And is anybody else getting to 3 decimal places? 0.903.
Okay, I'm sorry, what was?
We're typing this in right as it looks. 1 minus 22.8 over 235.8.
Minus.
Due to spacing, I'm only going to do every other one because the alternates are kind of repeats of the same idea. Can we look at 63?
Okay.
The word or tells me to add. So the probability that somebody is widowed, total number of widowed people are 13.9 over total number in the sample space. Or divorced, 22.8 over the total number in the sample space. And the word or tells me to multiply. Is everybody all right? Those ones are mutually exclusive. They don't have anybody in common. So when I add those with my calculator, to 3 decimal places, is anybody else getting 0.156?
Hang on. 2, 3, 5. Hang on, what was the process to just,
Adam, when I type this in, because those two fractions have the same denominator, I'm going to add the numerators
okay.
in parentheses and then divide it by the denominator.
I keep getting 1, 3, 4, 4 though. So how did you get?
Okay,
Oh.
everybody else in the room, what are you getting?
I got 0.155.
0.1556, that's going to
Yeah.
round up 0.156. Adam,
Okay.
check what you typed in.
I typed in, okay, let me, so first 13.9 times 22.8
Plus
No,
22.
plus.
plus. Oh, okay. I completely,
I'm sorry, I have bad penmanship.
no, my bad. Okay, so plus 22.8, and then divide that by 2. 1. Yeah, okay, I'm right now.
Okay, next one is probability, it's a male. So somebody want to tell me what's the fraction for males?
The fraction is total males or just
Yep, total males
114.
114.4, right?
over to 235.8, or, so we're adding. Total divorced is 22.8 over 235.8. But what do we have to be careful of here? Is there anybody that I'm counting twice? When I count
Oh
all
yeah.
males, I'm counting all of these folks. When I'm counting all the divorced, I'm counting all of these folks. And do you see there's that group that I'm counting twice? Those aren't
9.6.
inclusive. And so do you remember when we're doing that, or we have to always see, is there anybody I'm counting twice?
Okay.
The need to subtract clear to everybody. So I'm going to take that 114.5 plus the 22.8 minus the 9.6. And then I'm going to take that answer and divide it by 235.8. And is anybody else getting anything that looks like 0.542 when you round?
Yeah, that's what I got.
Next one says the person is a female, given that person is divorced. So over here, given that person is divorced, I am restricting my thinking to only the divorced people. So is everybody all right here? My entire sample space is the divorced people. So my denominator is 22.8. Of those 22.8, how many are female?
13.2.
So I'm going to take 13.2 and divide it by 22.8. And is anybody else getting 0.579?
Yeah.
And then lastly, I want to look at 69.
Okay.
69 asks, what's the probability the person is widowed, given the person is a woman? So given the person is a woman, I'm only thinking about women. So how many are in my sample space?
11.2.
Tell me where you're getting 11.2 from. Okay, I say
The female?
11, yeah, that's 11.2. Those are the divorced, widowed women. So that's going to be my numerator. But my denominator is going to be all of the women, 121.3. Over here, if I'm only looking at the women, I'm only looking at that column. And by column, I mean row, by the way. I'm sorry. I'm only looking at that row. So when I take that 11.2 and divide it by the 121.3, I get 0.092. And so when you see that given wording, we're restricting the sample space to that subset. And now there's one last topic that we have to look at this chapter. And I'm rethinking. Initially, I was planning on doing expected value with you, but I'm gonna just real quick pull up a calendar. If the test is on the 23rd, we can review on the 21st. So maybe I'm gonna push that last topic, expected value, back to the 19th. Would that hurt anybody's feelings? If I waited to add something new, and your homework then will just be on what we just looked at.
What did you say again?
So I was going to do one more new thing, but I'm looking at what we just did, and I'm thinking I'm going not. So I'm changing homework 13. Well, actually, no. Both those homeworks will be due on the 21st, but the content of homework 13 we will not deal with until Monday. I'm thinking let's stop here and not add one more last topic and talk really fast in the time that remains to get through it. Are you all guys all right if we stop here for today?
Yeah.
Sure, I guess.
Yeah.
Can I make sure you have me on attendance? I popped in like 2 minutes late.
Give me a second, Peter. Let
No
me go
problem.
back to that handout that we were looking at. Is everybody all right with these that we just did?
Yes.
I got it all down.
Wait a minute, don't roll it.
And I'm not wondering about getting it all written down. I'm wondering about getting it all in your brains. Is everybody all right with why 469, the denominator was 121.3 and the numerator was the 11.2?
Mm-hmm. Yeah.
All right. Peter, I got that you came in. Is there anybody else who came in late?
Me.
Taj, I think I got you. I think I saw you coming in. You were coming in just as I finished attendance, so we got you.
Okay.
Okay, thanks for letting me know, hon. Anybody else? Any questions on anything that we've looked at today?
Mm-mm.
No. I'm going to then stop sharing my screen. And I don't usually end class early, but you guys are way ahead of the other section. And I'm just looking at if that test isn't scheduled till Friday. I think if we spent the full 50 minutes looking at the expected value, it would be better than kind of trying to tack it on at the end of today and breaking it up in the middle. So you guys all right if we call it a day?
Sure.
Yes.
Okay,
For sure.
all right. Then have a good weekend.
All right,
Have
you
a
too.
medical weekend, and we'll see you on Monday.
All righty.
Okay,
See ya.
Sounds good. Goodbye.
bye-bye.
Miss Torella,
Yeah,
I have a question.
Who's
Uh,
asking the question?
I'm Janishala.
Okay, go ahead, Janisha.
I haven't looked at my quiz yet, but have you graded it yet?
No, I haven't. I have to apologize. I apologized at the beginning of class. We still have company in from out of town, and so I haven't been able to sit down and grade in the evening. I'm going to get all of that done over the weekend, and we'll go over the quiz over the weekend.
Okay.
Okay?
Great.
All right, and by over the weekend, I mean we'll go over the quiz on Monday. Okay?
Okay.
All right. Have a good one. Zorianne, do you have any questions?
No. Did you
No?
get me for I was having problems with my computer getting into Zoom.
Yeah, you know, I kept seeing you in the corner and it kept saying that you were trying to connect to audio and it wasn't working. But I did see you and I did get you.
Okay.
So, okay. Hey, you know what? If you have a problem connecting with the audio on your computer, you can always use your phone for the audio. So, all right. Kylie, do you have any questions? Omaro, do you have any questions?
Yeah.
Yes, go ahead.
A quiz. Can you email me that?
I'm still emailing you assignments, right? I will do that before the end of the day today.
All right, thank you.
Okay. Is there any chance of you getting the access code, or are we going to just be emailing you stuff all for the rest of the semester?
I'm gonna get the map.
You are going to get it? Okay, let me know when you get it. Otherwise, I will email things to you. With things like quizzes, what makes it hard is having it timed. So I'm going to have to just trust you that you're only going to take a set amount of time to do it, okay?
Yeah, all right. Because last time I took a quiz, you have an hour to do it, right?
The test you had an hour for. I think this quiz you have like 20 minutes.
Oh, all right, all right.
Okay, it's only 2 questions, though, okay?
All right. So do you want me to remind you to send it?
You know what? Why don't you send me can you at noon send me an email reminding me to?
All right.
Okay. All right. Thanks a lot. I appreciate you reminding me, and I'm sorry I forgot.
All right, thank you.
Okay, have a good one. Kylie, do you have anything you want to go over? Okay, all right. Have a good weekend.